Hello everyone, welcome to the fourth phase of the project building. Okay, so in this particular phase, we are going to be looking at the exploratory data analysis. All right, so the exploratory data analysis is the phase where we actually draw insight, okay, from our data sets. Okay, we have to visualize our columns, okay, and from visualizing those columns, we'll be able to draw insights, okay, from our data set. We'll be able to actually recognize seasonalities and trends, okay, and actually advise the companies, okay, and what they should not do. Okay, so you need to know that the exploratory data analysis is divided into three. Okay, we have the univariate exploratory data analysis, we have the bivariate exploratory data analysis, and we have the multivariate exploratory data analysis. All right, so in the univariate exploratory data analysis, what we actually do here is to visualize each of the categorical columns and each of the numerical columns. So what I mean by this is we'll visualize every columns in the categorical columns using a subplot. We also visualize every column in the numerical column using a subplot. Okay. Why when we talk about the bivariant analysis, we're actually trying to know the relationship between two columns. Okay. Where we have to visualize two columns to actually check the relationship between them, to actually check if they have a positive or a negative relationship, or if they are not related at all. That means the correlation between them. All right. So to actually make this video faster, because I don't actually want this video to be too long. Okay. So to make this video faster, I've actually written out all the codes, okay, for this video. I've actually written out all the codes, okay. So what I'll be doing is I'll be explaining each code, okay, to you, okay. I'll be explaining each code, okay, and we're actually going to be writing a story on its visuals together, okay. So for the course of this video, I will advise you that, okay, after going through these videos together, especially I did exploratory data analysis together, I will also want you to go through the codes, okay, understand the codes, okay, make more research on the codes, okay. This is actually how you learn, okay, and be perfect, okay, in actually doing exploratory data analysis. So now let's get started. So as you can see, we started from the univariate analysis, okay. So here I'm actually visualizing the categorical columns, okay. As you can see, I actually assigned the categorical columns to a variable named the cat vars, df cat vars, okay. So here is I plotted a subplot, okay, 4 by 2, okay, which means, okay, 4 rows 2 columns, okay. Okay, 4 rows 2 columns, okay. So this is what that means, okay. 1 2 3 4, okay, then 2, okay, 4 by 2, okay. So that's the subplot, okay. The fixed size is simply the size, okay. I've explained this earlier. The size we want the diagrams, okay, to have. So this is I used a for loop here to iterate through the columns, okay, to plot their charts, okay. So the next thing I did was I added the data labels, okay. So I added data labels to this, okay. Then I adjusted the layout space, okay. This is like adjusting the padding, okay. And this is the plt.show, which I told you that we use to actually show our diagram, okay. So when we go ahead and run this, so as you can see that we have successfully visualized the categorical columns, okay, of our data frame, okay. So if you can see here now that the segments, okay, we have segments with 300 columns, okay, 300 counts, okay. That means the government actually has a higher count, okay, compared to the other segments, okay. Then we have country, then we have products, okay. The count of the products for this product pasture is actually higher than the rest, okay. Then discount bound, we have high, we have medium, we have low, and we have none, okay. Simply means that the discount band, okay, the company gave higher discounts, okay, have a lot of discount bound in those high ratio. All right, so month name, okay, and the rest of them. All right, so the next thing we are going to do is visualizing the numerical columns, okay. Just like the same thing I did here, I actually assign, okay, the numerical columns to a variable. So when you come here, you see that I've assigned the numerical columns to these variable called columns, okay. So the same thing I did, I plotted the subplots, okay. So this is the same thing I did above. Then I wrote an iteration. I iterated using for loop, okay. to actually plot the subplot. Okay, so let's just go ahead and run this. So when we go ahead and run this, so you can see that this is actually what we have. Okay, so the next one we are going to look at the bivariate analysis. Okay, so the first thing we looked at is the country versus units sold. Okay, so in this situation I was trying to look at, we want to look at the country with the highest unit sold. Okay, so we went ahead to create the style. Okay, white grid. Okay, then we used Seaborn. Okay, create a bar plot using Seaborn. Okay, this is the fixed size. Then x is equals to country. Then y axis is equals to unit. So data, our D3, error bar, none. Then we added labels. Our x label is the country. Our y label is the unit sold. Then the title of our diagram is unit sold by country. Okay, so when we go ahead to run this now, as you can see, this is the diagram. Okay, then I reduce my image a bit more. So this is actually the diagram. Okay, so as you can see, Canada has the highest units. Okay, Canada has the highest unit sold. Okay, followed by France, then followed by America, then followed by Mexico, then followed by Germany. So let's just go ahead and write a story here. Okay, from this visual, we can actually write a story from the visual. From the diagram above, we can see that Canada has the highest dot units, is the highest units is sold, followed by France, then USA, USA, then Mexico, and Germany. The company should increase its supply to Canada and the United States. They should also carry out a study or analysis to know the reason for the increase in units sold in, in Canada and the United States. So they can use the same word for the other countries in order to increase unit sales. Let's go ahead and run this. Okay. So from this visual, we can actually see that Canada has the highest unit sold, okay, followed by France, followed by France, followed by France, okay, then followed by America, okay. So the story we are writing here is from diagram above, we can see that Canada has the highest unit sold, followed by France, then USA, Mexico, and Germany. The company should increase its supplies to Canada and France. Okay. It should also carry out a study or analysis to know the reason for the increase in the unit sold in Canada and France. Okay. So they can use the same approach for other countries in order to increase units. So, okay. So the next visualization we are going to be looking at is the products versus units sold. Okay. So in this very bivariate analysis, we are trying to know the products with the highest unit sold. Okay. Remember that we have different products. Okay. These companies deal on different products. Okay. So in this very analysis, bivariate analysis, we are trying to look at the products with the highest units sold. Okay. So just the same, all I did was to copy the same code and change the columns name. Okay. So SNS, that means Seaborn, figure size 1060, X products unit sold, DF none, then products unit sold by products, this then display. So let's go ahead and run this. So as you can see, this is the visual showing the units sold per products. Okay. So let's look at the product with the highest unit sold is Montana. Okay. As you can see here, that Montana is the product with the highest units sold. Okay. It has over 1,600 units. Okay, sold. Okay. So followed by, I think it's followed by this. Yes, it's followed by Passio, okay, then followed by Amarilla, okay, then followed by VTT, then followed by Paritara, then followed by Velo, okay. So this is just the visual showing the products with the highest units sold, okay. So we can go ahead and write a story on this. So we can say from the above bar charts, Montana, Montana has the highest units sold, followed by Pasio, May, Amarilla, Amarilla, Pasio, Amarilla. Then this one is Cavitera, Cavitera, and followed by BTT, right? Followed by BTT, and followed by Velo. Okay, the company should increase the production of Montana. Okay, we should also study why Montana has the highest unit told. Maybe it is on the marketing strategy or the ingredient or functionality of the products, and see if they uh, do the same for products like 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 below. In order to increase its unit. So, okay, so this is the story we can actually tell from this. Go ahead and boot this. All right. So the next thing we are going to be looking at is cost of goods sold, okay, and profits, okay. So for this, we are going to be using a scatter plot, okay, because scatter plot is actually used to visualize two numerical columns, okay, in order to know the relationship, all right, the correlation or relationship between them, okay. So for here, what I did was plot scatter plot, okay, as cost of goods sold, okay, profits, okay, data, which is our DF3, okay, scatter plot of cost of goods sold versus profits. All right. Then I added label. S label is our cost of goods sold. Then our Y label is our profits. Then PLT show. Okay. To show diagram. So when we go ahead and run this, okay, as you can see, we actually have, okay, our scatter plots here. All right. So now when we want to read this scatter plot, what you need to understand about this scatter plot is you actually look at these scatter plots now, okay, visualizing cost of goods versus profits. All right. When you study it properly, okay, you will come to realize that there is little or no relationship between cost of goods sold and profit. All right. For example, now when you look at cost of goods sold, okay, below, okay, 100,000, okay, you will see that there is a very high profit margin, okay, like up to over 50,000, okay. But when you look at the cost of goods sold of about 10,000, okay, you will see that there is a in when it got to 10,000, there's a high profit margin, okay, but the profit margin increases little by little, okay, as you can see, to up to 50,000, okay. So from what we can actually say from this now is that, okay, we can simply say that there don't seem to be a relationship, okay, between cost of goods sold and profits, okay. So the higher the cost of goods sold doesn't lead to higher profit, suggesting a weak or even negative relationship, okay, between these two. All right. So the next thing we have to do here is we went ahead to calculate the correlation coefficient, okay, to verify the type of relationship that exists between profits, okay, and cost of goods sold. The next variables we are actually going to be visualizing is the month versus self, all right? So in this visual, we are actually trying to know the months with the highest sales, okay? So like I said, the code is always the same. All you just need to do is to change the x-axis and the y-axis, then and you change the labels, okay? So that's basically all you have to do, all right? So when you go ahead and visualize this, okay? So what you will see now is that within January, okay, there is a dip in sale, okay, meaning that the company did not actually make much sales, okay, from January, all right? But you can see that they have their highest sales during April, okay? They have the highest sales during April, okay? So from this diagram now, from this line plot, we can actually see that there's fluctuation of sales, okay? When you look at the summer months, okay, you can see that, okay, there is a reduction in sales during the summer months, but the highest sell period is April, all right? Within April to, okay, May, okay, probably maybe because of maybe there was a promo the company was running, or maybe it is actually during a festive period or a celebration period. Okay, so now the next visual we are going to be doing is product versus sales. Okay, like I mentioned, the code always remains the same. You can always copy paste and just change the X and Y axis with labels. All right. So when we go ahead and run this, as you can see that the product with the highest sales is Montana. Okay. Then this is the product with the highest sales. Okay. Then I think it is followed by Caritera, okay, then followed by VTT and the rest of them, all right? So from this diagram, we can see that Montana is the product with the highest sales, all right? So we can simply write a story here, and down. The Montana is the product. Let us say the both diagram shows the variable, shows the cells are products, okay? From the diagram, Montana has the highest cell, followed by Caritana, by Caritera, and followed by GTT, and followed by Mira, followed by Manila, and Mesbis, Mission, and Velo, Homepage, Field, for the Montana, and Caritera. Know the reason for their high sales. They can introduce this strategy and discover strategy. Product like Velo, in order to increase sales. Okay, so the next one we are going to be looking at is, okay, go ahead and bold this please. So the next thing we are going to be looking at is the products versus profits, all right? So in this visual, we are actually trying to know the products with the highest profits margin, all right? So when we go ahead and do this, okay? So one thing you should notice here is that the product with the highest profit is VPT, okay? While the product with the highest sales is Motena, okay? So it is actually, people will feel like, okay, because Motena has the highest sales, so it should have the highest profits, okay? It's not that way, okay? We should factor things like returns, okay? It could have the highest sales, but also have the highest returns. We should also factor things like product price, okay? Maybe Montana is actually sold for $10, while VTT is sold for maybe $50. So these are things we should actually factor in. Okay, we should look at the price of the products, okay? We should also look at the returns, okay? And we also look at the cost, okay? The cost of production, okay? Cost of delivery and all these things, okay? So these are things that actually determines the product with the highest profit, all right? So as you can see, we have VTT as the highest as the product with the highest profits, okay? Followed by Caritera, okay? Followed by Caritera, then followed by Amarilla, okay? then followed by Montana, followed by Passio, then followed by Velo. Okay, so to write a story, we can simply say, okay, let's turn this to Markdown. From bar charts displaying from the bar chart above displaying the profits made by each product, we can see that VTT has the highest profit margin, followed by followed by is higher VTT. Why am I feeling like the profit margin? I think Artera is higher, followed by Tera, then followed by Amarilla, then followed by Montana, then followed by Casio and Velo. Okay, regardless, let's say, even though Montana has the highest sales, doesn't bring the highest profits to company. Okay, factors like, okay, the company should verify the reason for the low profits of Martina compared to VTT with a lower sell rate, and verify if it is as a result of cost of delivery, returns, or discounts, level of discounts. Okay, the company should increase the production and supply of utility as it brings the highest profits to the company. Okay, so okay, so let's go ahead and put this. So the next thing we are going to be visualizing is the country versus profits. Okay, so in this visual, we are actually trying to know the country with the highest profits. As you can see, we have actually checked the product with the highest profits. Now we want to know the country with the highest profits. Okay, so which country should the business, okay, or the company should be distributing more supplies to? So this is what we are actually trying to know. So when we go ahead and run this, so as you can see, the country with the highest profits is the United States of America. Okay, so it simply means that the country should actually look at producing and supplying more in the United States compared to countries like Mexico and Germany. All right, so let's go ahead and write the story for that. So do know that other things, a lot of things can contribute to the increase in the profit margin in the United States. Okay, it could be due to maybe lower cost of production in the United States. It could be to the cost of sale, that means the price of the products in the United States, and also the purchasing power in the United States. So it could actually be that the people in Mexico has a lower purchasing power, okay, compared to the people in the United States. Therefore, the companies actually increase the prices of their goods, okay, in countries like the United States and Canada and France compared to companies like Mexico. Okay, so these are things we should also consider. We should actually look at cost of delivery in the United States, the level of returns, the discounts given in the United States. So these are things that can actually affect the profit margin in each countries. All right. From the bar charts displayed above. Okay, so this is it for this. So let's go ahead and build this first. So the next thing we are going to be looking at is segment versus profits. Okay, so in this particular diagram, okay, analysis, bivariate analysis, we are actually trying to know the segments that is actually more profitable. All right. So if you can see, the company has different segments. It has the government, the mid-market, channel partners, enterprise, and small businesses. So when you look at this diagram, you can see that the small businesses is actually the most profitable segment. Okay, and the lowest profitable segment is the mid-market. Okay, so looking at this diagram now, we can simply advise the company to actually invest more in small businesses, okay, since they actually give them the most profits. All right, now let's go ahead and write a story for that. From the diagram above, Okay, so this is it the for this particular vision. So let's go ahead and put this. All right. So the next thing we are going to be looking at is product versus cost of goods. Okay. So product versus cost of goods. So we want to know the cost, okay, of producing the good, each product. All right. So like I mentioned, the code is always the same. So you can always copy, paste, and just adjust the x axis, the y axis, and the labels. All right. So let me go ahead and run this. Okay, as you can see here now, Montana has the highest cost of production. Okay, Montana. So if you look at this, all right, for this particular sales by products, okay, we can see that Montana has the highest sales, okay. Montana have the highest sales, but it doesn't have the highest profit level, okay. Now I think this answers the question why Montana doesn't have the highest profit level, and that's because it has the highest cost of production, okay. As you can see, the company incurs more costs, okay, when producing and delivering Montana compared to other products. Okay, so that is the reason why Montana doesn't have the highest profits, even though it has the highest sale. Okay, now let's go ahead and write the story for this. Montana has the highest cost of goods. So this simply means that the company pays more in the production of Montana compared to other products. Okay, the company would look for a means to reduce the cost of purchase from Montana. Okay, in order to maximize its profit margin. Okay, margin. Okay, they should also consider increasing the price, selling price, selling price of now. Okay, so let's go ahead and put this. All right, on this. All right, now we have gotten to the multivariate analysis. Okay, so when we are talking about the multivariate analysis, we are actually trying to analyze more than two columns. Okay, it could be four columns, it could be three columns. So we are actually trying to analyze more than two columns. Okay, so to actually get insights and to actually recognize trends. Okay, and also give the business advices on how they can actually increase their profits and reduce their cost of production. All right. Firstly, let's go ahead and see our numerical columns. Okay. So let's go ahead and run this. Okay, so as you can see, this is the we are actually visualizing segments, okay, profits and country. Okay, so as you can see, this is I actually added a legend here. Okay, so this is governments. Okay, governments. Okay, so this is mid market. Okay, so this is channel partners. All right, so this is enterprise. Okay, and this is small business. Okay, this is small business. Okay, so as you can see for Canada, okay, as you can see, the profits for governments, okay, is this. All right, then for the same Canada, the profit for mid market is this. Okay, then the profit for channel partner, okay, is this, okay. The profit for enterprise is this, and the profit for small business is this. So as you can see now in Canada, it simply means that the most profitable segment, okay, is the channel partners. All right. Now remember, when we go above, when we visualize segment by profits, okay, we realize that the most profitable segment is small businesses, okay, small businesses. And over here, we advise the company to increase their business transactions across business transactions across small businesses, okay. So now when we go below here, we can actually see, now we can actually get more insight into why and how small business, okay, is actually the most profitable segment across all countries, or across most countries, okay. So as you can see, for Canada, the most profitable enterprise is the most profitable segment, sorry, is channel partners and not small businesses. Now, when we go over to Germany, we can see that the most profitable segment is small business. When we go over to France, we can see that the most profitable segment is also small business. Then when we go over to Mexico, we can actually see that the most profitable segment too is small business. And when we go over to the United States of America, we can see that the most profitable segment too is small business. All right. So we can actually say that the most profitable segments, okay, for all across three countries, okay, across one, two, three, four countries is small business, okay. Why the most profitable segment in Canada is channel partners, okay. So we can actually say that the company should actually increase, okay, they should actually increase their small business transactions across Germany, France, Mexico, and the United States. And they should also increase their channel partners business transaction, okay, in Canada, okay, in Canada, okay? Because over here, now, when you look at this diagram now, you can see that in Canada, small business is not the most profitable segment, okay? Unlike other countries where small business is the most profitable segment, okay? So we can go ahead and write a story for this. So we can say from the diagram above, profitability of each segment across the various countries. We can see that for Germany, France, Mexico, and USA, the most profitable is small business, unlike in Canada, where the most profitable segment is channel partners. Partners. The company should increase their business transactions in small businesses across Germany, France, Mexico, and the United States. And they should increase their channel partners business transactions in Canada, as it is the most profitable segment in Canada compared to small business, compared to small business. Okay, so this is it for this particular visualization. All right. So the next thing we are going to be looking at is the cost of goods, profits, and products. Okay. Now let's visualize this. It's coming up, coming up. Okay. So this is a pair plot. All right. So this is a pair plot showing cost of goods sold, profits, and products across all the numerical variables. So the last thing we are going to be looking at today on the course of this our project building is the correlation coefficients. All right. So the correlation coefficient, I actually have plans of making a video on heat maps, okay, where I'll be explaining what heat map is, and where I'll be explaining how you can also actually read heat map and how you can actually use heat map to actually study and understand the relationship between your variables. Okay, but before then, I would like to mention that when calculating your coefficients, the coefficient correlation or your correlation coefficient, okay, we only make use of our numerical columns. Okay, you don't make use of your categorical columns. Okay, categorical columns has no business with correlation coefficient. Okay, so we only look at figures. Okay, and the only way we can get that figures is from our numerical columns. Okay, so it's through the figures, okay, that the heat map can actually tell if one variable is actually related to the other or not. Okay, so one thing you need to understand is that heat map, okay, actually has a figure of 1 to -1. Okay, 1 indicates a strong positive relationship. Okay, -1, values from -1 indicates a strong negative relationship, while values out of when we get 0, it indicates no relationship. Okay, now the first thing I did here was calculate the correlation coefficient. What I did was I declared a variable which I called correlation matrix, okay, is equals to norm. This is actually our numerical columns, okay, dot core, okay. So to calculate the correlation coefficient, okay, of your numerical columns, you make use of this dot co, okay, which simply means correlation, all right. So the next thing I did was I displayed the correlation matrix, okay, like this is what we have been doing ever since we started working on this project. Okay, so this plt dot figure is simply us setting the size of our heat map. Okay, then this is us plotting our heat map. Okay, poem, okay, is just like a color. I will actually explain that better when we actually have our heat map displayed. All right, so plt dot title, this is just us giving it a title, which I called correlation coefficients of the financial data sets. Okay, then PLT.show, okay, actually to show our heat map. All right, so let's just go ahead and run this and see what we get. Oh, so here it is, all right. So one thing you need to understand about heat map is that heat map is actually used to quantify the relationship between two or more numerical variables. Okay, so that is what you need to understand. Heat map is used to quantify the relationship between numerical columns. All right. So now this is what we call pool. Okay. So it's just like this is just like a column, okay, a mixture of colors, okay, indicating the correlation type, okay, like if you see the red, okay, the red correlation, like the red color now, the dark red indicates a strong positive correlation. All right, then when you go to the dark blue, this indicates a strong negative correlation. Okay, but when you come to this area, this indicates a weak correlation or no correlation at all. Now, I will just go ahead and explain two or three relationships here to actually give you a better understanding of what I'm saying. Now let's look at the relationship between units sold and, okay, which one should we go for? Okay, let's look at the relationship between units sold and cost of goods sold. Okay, units sold and cost of goods sold. Now, the first thing I would like to explain is what is cost of goods sold. Okay, cost of goods sold is actually the entire cost incurred in producing or manufacturing the finished goods. Okay, so the only costs actually associated or added to cost of goods sold are the costs that are directly, okay, incurred during production. Okay, like materials and manufacturing overheads and the rest of them and the rest of them. So all you need to know is that cost of goods sold is simply the cost, okay, of manufacturing the finished goods. Okay, so the only costs added to the cost of goods sold are the costs that are directly related to the production or manufacturing process. All right, now this is what unit sold. Okay, unit sold, what is unit sold? Unit sold is simply the total number of product or finished product that is actually that is sold to the final consumers. Okay, now when you look at this, the relationship between units sold and cost of goods sold, you can see that we have 0.95, okay, which indicates a strong positive relationship. Okay, now what is this trying to say? This is trying to say that an increase in units sold, okay, will lead to an increase, okay, in cost of goods sold. All right, now let me explain how that can happen. Okay, now we said that the more units you sell, okay, the more cost, okay, you incur in production. Okay, like if we say we incurred a total cost of sales of $5,000 for producing 10 units of value, which is one of the products the company sells. Okay, we incurred a total of 10,000 of $500 or $5,000, a total of $5,000 as expenses for producing, let's just say, 10 value units of value. Okay, if we wish to produce another 200 units of value, it simply means that we are going to incur additional cost of goods sold. Okay, so what is this trying to say? This is trying to say that an increase in the units of sales will lead to a significant increase in the cost of goods sold. All right, now let's look at something else. Okay, now let's look at manufacturing price. Okay, let's look at manufacturing price, and let's look at manufacturing price and discounts. Okay, manufacturing price and discounts. Okay, now when you look at manufacturing price and discounts here, now you will see that this is a very weak correlation. Okay, now when we talk about discount simply means the amount of money, okay, the amount or the cost removed, okay, from the total, from the unit price of an item to a customer. Okay, it will be that, for example, a company decides to run a promo or slash the prices of their goods. Okay, they can say that a unit of value goes for $10. Okay, but because of this promo we are having, we are going to be giving a unit of value for $5, making it, or like they slash the price of value by $5. Okay, so this is simply telling us now that there is a very weak relationship between discounts and manufacturing price. Okay, so it is simply telling us that a decrease in the manufacturing price, okay, a decrease in the manufacturing price does not necessarily lead, okay, to a decrease in discount. Okay, it does not necessarily lead to a decrease in discount. Okay, so this is what this is actually trying to let us know. The next one we should look at is gross sales. Okay, and let's look at gross sales, the relationship between gross sales and sales. All right. So now, if you look at this, you will see that the relationship between gross sales and sales is 0.94, which indicates a strong positive relationship. All right. Which means that an increase in gross sales, okay, or an increase in sales will lead to an increase in gross sales. All right. Now, let's explain this way. Okay. What is gross sales? Gross sales is the total amount of revenue gotten, all right, from sales, okay, without, before minusing any expenses. All right, now when you look at this, now this is sales. Okay, it simply means that the more sales, okay, that the company makes, the more gross sales, okay, that they will have. All right, the more sales they make, the more gross sales they will have, which is correct. Okay, because for example, if a company sells 10,000 units of products, okay, it simply means that they will have, maybe if the, we- when we s- if the let me say the 10,000 units of product they sold, okay, is for $10,000, okay. It simply means that they will have a gross sales of $10,000, okay. And if they make a sale of 20,000 units, okay, and the total amount they actually get from sales is, let's say, $20,000, it simply means that they will have a total gross sale of $20,000. So simply means that an increase in sales, okay, will lead to a significant increase in the gross sales, okay.